This conference will now be recorded.
So in this specific session, we will start with discussion of web application vulnerabilities. We'll actually perform some attacks and try to explore what are the vulnerabilities inside the web application. So let's first start with discovering something called as parameter tampering. The ASM application which is going through RF5 is this specific application. My first step would be to log in as a valid user. So here I have my prompts asking for username and the password. I will enter my details. Now I have logged in as a valid user. I click on control panel. Once I click on control panel, in here I will be able to see my specific user details. Okay, so now when I'm logged in and moved to this specific location, the URL in the URL, if you notice, the URL is saying as nick is equal to student 10. So in here, in this specific complete URL, nick is the parameter. Nick is referred as parameter, and student 10 is referred as a value which is given as an input to this nick parameter. Nick parameter is integrated within the application itself, and student 10 is its value. Now, being an attacker, what I'll try to do is I'll try to exploit the vulnerability in this specific application. So at present I have logged in as student 10. I will try to see, I will modify the value of this parameter without logging in to other user accounts, and I'll see whether I can see any other users details or not. So I'll just move this to from student 10 to student 20. So at present I can see this control panel is showing student 10 details. Okay, I will move this to student 20, which might be any other student, and give enter. See, the moment I uh, entered this, I'm able to fetch and get the details of student 20. So in this, what has happened is I've tried to modify the value of nick parameter, and I am able to see the details of any other user from the backend's database. Even though I am not logged in with his ID, I am able to see his information. Let me try to replace this with asterisk and give enter. So this way is you can analyze that I am able to view all the information, and I am able to get all the details from the database with respect to various users. So this is one way in which you try to exploit the vulnerability. You understand that, okay, this is parameter. If I'm trying to manipulate it, the server is actually responding to me. So I can fetch crucial information from the database, which I can use later on to perform malicious activities. Next is we'll try to perform hidden field manipulation. So in this, we'll first go to home. Let me open Fiddler. I'm just trying to click on any of the random links. I go to Fiddler, and in here I go to rules, automatic breakpoints, enable the before requests. Wait a second. Enable the before requests option in Fiddler. I went to one of the pages where I get an option to buy the objects. So from here, it is saying as the price is 40 USD for this camera. I click on buy it, and then I go to my request. It went. Okay, I go to my request and then click on web forms, and this is where I can see my price parameter, which has a value of 40 USD. So in this specific option, what I'll try to do is, instead of 40, I'll edit and select 4, and then click on run to completion. Let me go back and see that price has changed now to 4 USD, and I'll confirm that I've bought the item. See, your credit card number will be charged with 4 USD. So this way what I've done is I have achieved a hidden field manipulation vulnerability. There is a hidden field called price. I modified it and achieved my goal. So instead of purchasing that item in $40, I have purchased it only in $4. Then next comes option of, let me first disable this option. Something which is called as forceful browsing. So when I say forceful browsing, it means that I as a hacker know that maybe this application is hosted on Apache kind of server, Linux, or a specific web frame. I know how the directories are created on that specific server. I know where password files are located. So I will try to do a forceful browsing. So I'll try to look for some standard files within the application. So in here, I will go to the website. Let's say I just then type includes. See, I'm able to see this. So inside this include directory, there are multiple other files. So I now know that these are different files which I can even access. So let me go to includes.config.inc.php. This file maybe does not exist. Let me try php.old. It's not loading. Let me click on this. For some reason, it's taking a long time to respond. But the main idea behind this specific attack is to explore and try to extract some information which is crucial to the server. So we are forcefully trying to go to those directories which ideal user should not have access to. Let's try something else. Let's try to perform SQL injection. So in this SQL injection attack, what we do is we first go to
So,
the, yeah.
Vinit,
Mhm.
the previous one that we were trying to access the some of the directory which are like critical to the user. What kind of attack is that called? Like,
Forceful browsing. So we are trying
okay,
to forcefully identify some directories inside the server. Maybe there would be a file for passwords. So I can try to get that file, see the contents of those file. I
okay,
can, using that information, I can do anything mischievous.
okay, got it. Thank you.
Yeah. So let's try to perform SQL injection. So first thing is I'll log out from this application. After logging out, I will just, in the username field, I'll type, so even this has been given as an input to the database, the backend database. So even though this is not a valid user, once I clicked on login in, it allowed me to log in. And if I click on your control panel link, I'm able to see the all users information. That's because this query, which is injected as a SQL query to the application, will be valid in all cases. So 1 equal to 1, it is always true. So database has given you all the information that it has with respect to the various users. It has allowed you to log in. So this is something how we perform SQL injection attack. Now with respect to these attacks that we have seen, now we'll try to use ASM and mitigate these attacks. We'll try to develop some security policies on our ASM and see how we can mitigate these vulnerabilities. So our next section would be security policy deployment. Whenever you create a security policy, right, there are two approaches to it. One is your positive security model, and the other is a negative security model. Let me give you a very simple example of these security models. Okay, so ASM is nothing but like a watchman. So let's say this is a bank ABC. Bank name is ABC. Bank has deployed a watchman here on the gate through which everyone comes in and goes out. So when I say I will tell my watchman that if anybody with the name of Rahul, Raj, If anyone with these names come to the gate and try to enter it, please allow it or allow them to enter the gate. Apart from these people, if anyone else is trying, let's say Alex is trying to enter, or anyone else, I don't care, whatever the name is, do not allow it. Do not allow. So this becomes an example of your positive security model, wherein you have defined what things are good. What is it that you know that will not perform any harm in your application? Now, similar to this, I can also tell the watchman that anybody with these names should not be allowed, and rest all, because I know these are bank robbers. So I know these are bad people. Or maybe I'll just uh, show the photos of these people with their ID cards, and I will tell the watchman that please do not allow them. So this is, and rest all, apart from these people, rest all you can let them enter. Let them enter into the bank. So this would be an example of your negative security model. Now comes the question of how or what should be your approach towards developing a security model. So whenever we define a security model, it is something like, let's say you have a client machine, you have a server. In positive security model, you will be defining what are the allowed file types, what are the allowed URLs, what are the allowed parameters which can be requested, or the request from client can be allowed to reach to the server. And then when server is responding back, what are the allowed HTTP response codes. So we must define what is actually our legitimate traffic. This approach would be called as positive security model. And similar to this, if I talk about, this is positive. Similar to this, if I want to compare it with negative security model, we have a client, you have a server. In here, you will be defining various components, whether it is RFC compliance, whether it is trying to perform any evasion detection, or if the request is matching any attack signatures. Then it reaches the server. From server, in the response, you will find um, if any server is responding with any crucial data, critical data, credit card information. So you have a feature called as data guard, which we'll discuss later. Then again, in the response also, you can see if the response is matching attack signature, and then send the response back to the client. Whenever you are actually deploying a security model, you should consider a combination of both as a best practice. So not only positive, not only negative. So you should try to bridge the gap between this. When you are trying to build the security policy, let's say positive is up to this level, negative is up to this level. If you want to avoid the false positives, you need to ensure that the difference between the positive and negative is as less as possible. You need to consider various things when you are trying to build the security policy. So how many applications need it? How complex are those applications? And how often maybe the applications change? And with respect to that change, how do I cope up with my security policy? How much time I have to build a security policy in an accurate manner? So till this part it is clear.
Yes.
Okay. So I think for today we'll stop it here only because the next is again a new topic. We'll start it up tomorrow.
Okay, sure.
Okay.
Thank you.
Thank you guys.
Thank you. Bye.